What is up, hackers, game devers, and security enthusiasts? Today, I want to talk about one of the most overlooked topics when it comes to cybersecurity students and people trying to get into things like hacking in the first place. Networking is really the foundation of a lot of security, right? Understanding networking is the foundation to understanding security tools. It's the foundation to understanding how to get inside of a network to compromise somebody and then how to actually exfiltrate. Right? If you can get someone to download your malware, but you can't actually communicate back to your command and control, then you can't actually get anything, right? So networking is incredibly important, and it is such a vast field. It's very important that we understand a lot of this as security people or hackers, right? So today, I kind of want to just give you guys some motivation and the tools to go work on some networking projects and to look up more networking information in detail. But today, I just want to talk about the language that we use to talk about networking, give you guys some very high level, some very brief kind of rundown on how lots of networking stuff works, and we'll go from there. So the very first thing I want to start talking about is the OSI model. Now, if you guys have heard anything about networking, you guys have heard about this. This is just a model with 7 layers that we use to describe different networking processes, right? So networking, because it's so complicated, we kind of break it down into these 7 different layers. And depending on what type of work you're doing, maybe, you're actually setting up physical connections, or maybe you're developing applications. Maybe you're like a software developer, so you're like coding this kind of network infrastructure. Maybe you're a sysadmin setting up these applications. Maybe you're a network engineer who's setting up the routers and the switches and everything. You're going to be dealing with different spots with different layers of the network. As security enthusiasts, as hackers, we have to kind of have a high level understanding of all of them. So we know what's going wrong, and we know different vulnerabilities and different issues can happen at all these different layers. What do those look like? How do we prevent those? How do our security tools work with those? Like, we're going to talk about firewalls today and how firewalls used to work on layer 4, but now they work a lot on layer 7. But we'll get into all that. So I'm going to start from the bottom and go up, because to me, that's what makes most sense. So layer 1, and when you're talking to people in the industry, you'll often hear people call them by the layer number and not the name. So it's helpful to know both. But layer 1 is the physical layer. So the physical layer is what it sounds like. It's literally the wires connecting the computers, right? Or the endpoints. So your Ethernet cables, those copper cables, fiber cables, right? People who are dealing with layer 1 physical stuff in networking are dealing with like different types of adapters and the actual wires and the twisted pairs and all of that physical wiring stuff when it comes to networking, how the actual bits of data get from point A to point B. That is not something that us as security folk have to worry about too much, but again, it's important to know, like, what do different adapters look like, and what are common, how is your internet coming to you? Is it fiber? Is it coax? All of that kind of stuff. That's all layer 1. Layer 2, this is probably the first most important layer. This is called the data link layer. But again, in my experience, I'm mostly calling it layer 2. This is responsible for formatting the raw data stream that comes in from layer 1 and sending it along its way. So I'm going to start by drawing a simple little diagram here where we have 2 computers, and these computers are going to be connected to a box. Now this box, we're not really going to talk too much about the box quite yet. Actually, we'll just go ahead and say that this is a switch. And what a switch is responsible for is taking in this data that comes in from the computer, seeing the MAC address that its destination MAC address, and sending it along to the destination MAC address. What is a MAC address? That is also called a physical address. This is something that your network cards have that are on your computer, right? So this little network card, the little port that you plug your Ethernet cable into, that has a physical address called a MAC address. And that is how layer 2 communication works. It works off of that MAC address. Back in the day, before we had switches, we had these devices called hubs. And what hubs would do is a frame. These are called frames. When your network card frames up some data and sends it along, that is a frame, a layer 2 frame. When that layer 2 frame would hit the hub would send it out to all the other devices connected to the hub. And it was the endpoint's job to say, hey, that physical address, that MAC address in that frame header doesn't match my physical address, so I'm going to ignore it. And we're not going to worry about that frame. Obviously there's some some issues that come up with that, like when your networks get bigger and you start to have like collision errors. You can't really plus you could maybe spoof your physical address. Like, you're still getting that physical data, so there's ways that you can access that, whatever. Now modern switches are able to they decide where to send it. They say, okay, so this port is connected, let's say this is port 2, this wire here, this is port 2 on my switch, and we'll say this is port 1. So port 2 I have associated with this guy's MAC address. So the switch is smart enough to say, okay, well, if the MAC address matches the MAC address I have lined up with this port 2, send it along. So now it's not just sending out all of the frames to all of the other devices that are plugged into it. So this is what layer 2 communication is. This is a local area network. This is a LAN, right? If my old gamers used to have LAN parties, like, we were all on the same local area network. We were on the same layer 2 network. Now, one of the most important things when you're getting into enterprise networking is this concept called VLANs. What VLANs are a way to, with the same switch, segment certain ports into different local area networks. It's layer 2 network segmentation. So the way that works is when I'm sending a frame, it has the MAC address that it comes from. We call it the source. It has the MAC address that's going to. It has the destination MAC address. And it has some other things, like it has a checksum at the end to make sure that if any of the data gets changed or altered and that checksum doesn't add up properly, say, hey, that's something went wrong somewhere. That's not a valid frame. But we can add in a VLAN tag. A VLAN tag is just any number between 0 and I believe it's 4095. Again, I'm not perfect at this stuff. My job is just to give you guys a high-level overview. Whatever you guys think is interesting, go do more research on it. But we're going to insert a VLAN tag on our frames now. And now we can say on our switch, I want port 1 to be on VLAN tag 10. And I want port 2 to be on VLAN tag 20. And now those are going to be put into the frames. And now if a frame comes in that's tagged with VLAN 10 on the switch, it will only be allowed to go out of ports that have been set up on the switch itself to allow VLAN 10 traffic to go through it. And same thing for 20, right? So now, if I set this up this way, these two computers will not be able to talk to each other. They're on the same switch, but they're on two different virtual switches, basically. They're on two different VLANs. And so when you're doing like enterprise, you're setting up these switches, a lot of the work is booting up the switch, going into the command line and configuring, hey, this port is going to be on this VLAN, this port's going to be on this VLAN, Maybe I want a certain port that goes up to my router. Maybe we have port 3 here that goes to the router, and I actually want all of the VLAN tags here. We call that a trunk port. So if you guys think that this is something you're interested in, practice this in Cisco Packet Tracer. Cisco Packet Tracer is a free piece of software that will allow you to actually set up switches like this, set up endpoints. You can practice configuring VLANs, trying to get these computers to ping each other without the VLANs, try to get them to ping each other on different VLANs. What are you going to have to add if you have these on different VLANs and you want them to ping each other? And it will actually give you the command line of a fake Cisco switch that you get to go in there and type in the actual commands to configure the switch, like a Cisco switch. That is invaluable experience. If you're looking for security projects, that is a phenomenal way to dip your toes into networking and enterprise-related networking. So go do that. All right, so we're going to be expanding on our layer 2 diagram by adding in a layer 3 device. This is, usually these are routers, but some new enterprise level switches can have layer 3 routing functionality. Now, layer 3 devices are responsible for routing things on different local area networks, right? So in our previous example where we had 2 different VLANs, if you want to get those to talk to each other, you're going to need a router that says, hey, when I want to go to this place, you need to get routed through that router. So layer 2, we talked a lot about MAC addresses. Layer 3 is where IP addresses come in. And the most common IP address, which is the one I'm sure you guys are most familiar with, is IPv4. IPv4 addresses are just 4 8-bit addresses. So they're called octets. An example would be like, 10.0.17.5. That's an example. These are 8-bit numbers, which means each one of these things separated by the periods can go up to 255. So you can have 255, 255, 255, 255, right? That's kind of how we understand these. Some of these are reserved for private IP addresses. A lot of them are public IP addresses. So this, for example, is a private IP address. Anything that starts with a 10 is a private IP address. A lot of networks that start with like a 192.168, that is also a private IP address. In fact, that's probably what your address is. It's probably something like this at home. But this is a pretty common scheme as well. This is more what my IPs look like, but this is something that you can actually go change when you're messing around with your switches and your routers and your endpoint IPs. So let's go ahead and set up a little network here. We have them on 2 different switches, so they're on 2 different LANs. Now we have to decide, how are these guys, we need to give them layer 3, a way for the layer 3 part of the networking for them to kind of understand each other. So we need to give them IP addresses. We're going to give each layer 2 network a range of IP addresses. So the most common way to do this that you'll see is giving it a subnet. So we're getting started with subnets here of 255.255.255.0. And then we can say, we'll say 0.2.1. We'll say this is the IP address for our switch 2 here. Now, this subnet mask, what this is saying is the numbers that are 255, those are going to be reserved for the network. The last little number here is going to be reserved for the endpoints. So in 10.0.2.1, this number, the 10, is reserved for the network. This is reserved for the network. This 2 is reserved for the network. And this 1 is an actual endpoint. That means we have 255 endpoints that we can use with a subnet that is this big. To get a little bit more technical, because there are a couple different ways to write subnets. This is the most common way you'll see it. Like, this is how Windows writes their subnet. So if you go open your network adapter settings and you go look at your subnet, it's probably going to be that. And whatever the first 3 octets are, 129.168.whatever, you know that the first 3 octets, the 129 and the 168 and the 1, are all belong to your network. 72, that is your computer on your network. That is your endpoint. What a subnet is it's actually just the actual binary of a subnet is, okay, so we know these are 8 bits. That means it's 8 ones or zeros. A subnet is a series of ones. That's 8 ones. That's the first octet. Or 1, 2, 3, 4, 2, 3, 4. Oops, 1, 2, 3, 4. Dot 0. And this would be 0, 0, 0, 0, right? That'd be 8 zeros. So that is this translated into binary. Now, the reason I'm writing this out in binary is because the other most common way of writing subnets, and this is something that I think is a little bit easier to understand, and it is personally, you'll see it in like Linux and Mac a little bit more when you're doing more configuration with that. They call it CIDR notation. In CIDR notation, you just count the number of ones before the zeros pop up. So here, 8, 16, 24. So this subnet you could describe as /24. So we could say we're on the subnet of 10 dot, I forgot the numbers we're using, but let's just say 1.1. And then we'd say 0, because this is what our endpoints are going to be, /24. This is the same thing as writing 255.255.255.0 and writing that beside it. These 2 lines are equivalent to this line because of the binary. Now, when you understand the binary, you can actually do whatever you want with subnets, and you can go online, you can actually type in some calculators. Like, we can go say, okay, let's say I don't need so many addresses. I don't need 254 addresses with this subnet. This subnet's too big for what I want to do. So let's make it smaller. Let's say I only need 4 bits of data. 4 bits of data would be what? 2, 4, 8, 16. I maybe only need 16 addresses. Well, the way that you would write that out, or the way that you would go about figuring out how to write out that subnet address, is you would start with the binary. So it's going to look the exact same for the first 3 octets. We're just going to add 4 more ones. 1, 2, 3, 4. 1, 2, 3, 4. 0, 0, 0. 0. It's going to be 4 zeros here. And you guys might be cut off here, so let me move us down a little bit. All right. Now, the way that you would go about figuring out how to write this is you would figure out what this is not in binary. You would translate this out of binary into like kind of a normal base 10 number. Now, luckily, there are calculators for this, so I'm just going to go ahead and pull up a calculator and I'll put it on screen. But the CIDR notation for this would be 24. We just added 4 ones, so it would be /28. So /28, you get less IP addresses. As the CIDR number gets bigger, you get less IP addresses for the endpoints. This number written out looks like it would be 255.255.255.240. And if you know your binary math, you can go ahead and check that yourself. And that's always a good exercise to do. But this is a subnet mask that isn't very common, but is, once you know how the binary of how subnet masks work, you can start to mess around with things like that. And in fact, I highly encourage you to do that. That's something I did when I first found out that subnets are literally just a string of ones. And when the ones end, that's the endpoints that you're allowed to use on the network now. It's like, oh, I can use some really weird subnet ranges. Like, what if I use 255.255.255.128, right? What would that look like? Which, if you guys know your binary math, you would know that is just the first one here. I just add an extra one. So in CIDR notation, we would call that a /25 subnet address. So these two ways of writing this are equivalent. They're equivalent because of the binary. Okay, so that is subnets. Okay, so that is subnets, especially with kind of more standard IPv4 addresses. Usually when people say IP addresses, that's what they mean. The other type of IP addresses are IPv6 addresses. Now, these addresses are just way longer, and they're not used too much. But if you go like ping google.com right now, you'll probably see an IPv6 address come back at you. But we're not going to worry about that too much. That's beyond the scope of what we're talking about today. And that shouldn't be too necessary for you to worry about. Coming back to our layer 3 network, now that we know how to set up subnets, which are a very, very big piece of understanding layer 3 IP addresses, the only other part to routing and layer 3 networking is understanding that you have to point the IP subnets to each other, right? So, you guys have probably seen something called a default gateway. A default gateway is where your data is going to go when it doesn't know where you're addressing it to. So say that computer 1 here is trying to get to computer 2, and you type in its IP address. It's like, I don't know where the heck that is. It's not on our local area network. Okay, let's send it to the layer 3 guy. That's where your default gateway is. So this number pretty much always is going to be your router or your device that handles routing. The reason I say that is because a lot of the times in an enterprise situation, the device that handles your routing is going to be your firewall, but it could also be a layer 3 switch. So these are the different devices that this could be reporting to. A layer 3 switch is layer 3 because it has routing functionality. Pretty common, like standard practice for this will be the first IP address in the range for your network. So let's go ahead and write down some IP addresses here. Let's say that switch 1 is going to be on network 10.2.2.0/24. We'll say this is going to be the IP range for this. Oh, these switches are going to get backwards. Let me go ahead and just erase these really quick. Oh, did not know I could pull open a ruler. I'll say switch 1 and switch 2. Switch 1 IP address will be 10.1.1.0/24. Again, we talked about what that means in the previous section with subnets. On the router, we're going to say, okay, this interface on the router pointing to this, we're going to give that the IP address of 10.1.1.1, the first IP address in this subnet range. All right, so that's going to be your most common practice. So then what would the IP address be for this interface on the router? Well, probably 10.2.2 because that's the network we're on. Now we're on the endpoint, .1. That's going to be most common. That means now our IP for our switch and our endpoint on this could be anything from 10.2.2. So it's going to be, this is going to be the start, but that last number can be anything from 2 to 254. So you can go crazy. You can go set that up statically on these. You can set up you can set it to dynamically get an IP address in that range. Dynamic dealing out IP addresses is called DHCP, Dynamic Host Configuration Protocol, I believe is what that stands for. So that is something, if you're setting up a kind of network in your home lab, look into DHCP. See, what devices can handle that for you. How do you set up a DHCP server? All that kind of stuff. We'll get into it a little bit later, but there are some open source firewalls that you can install on virtual machines that are the way to practice this kind of layer 3 routing and subnetting and network segmentation in your home lab with just one device. The device you're watching this on, assuming it's a computer, you can go download VirtualBox and practice these concepts we're talking about. If you want to get into security, if you want to learn how to hack into networks and how that works, you got to get this stuff done in the home lab. So let's go ahead and finish our little IP scheme here. Let's go ahead and say that switch 2, we're going to give an IP address of 2. Well, okay. Each device is going to need an IP address. We need an IP address. Just going to write IP address like that for short. It's going to need a default. It's going to need a subnet as well, so it understands what network it's on. It's going to need a default gateway, which is, hey, where do I send my stuff when I don't know where to send it, right? Like if it's not on my local network, where does it go? Again, usually this will be your layer 3 device. And then it needs a DNS server. Now here, I'm going to go ahead and erase this because it's kind of getting in our way here. So on each device here, we can go in and decide each one of what that's going to be. So we can say for switch 2, the IP address, let's have it be 10.2.2.2. Because our layer 3 device is going to be our .1. I think that makes sense. You can have that last number be whatever you want in between 2 and 255. The subnet for this, we can write it a couple different ways. We could say /24. Or we could say 255.255.255.0. The default gateway, what's that going to be? That's going to be our layer 3 device. That's going to be this interface. So, hey, if something comes to me that I don't know what to do with, send it up. Send it up. That's what we're going to do. So we're going to send that to 10.2.2.1. DNS, that is, that's how you resolve actual domains. So when you type in google.com, like, hey, ping youtube.com, where are we going to go to figure out the actual IP address of youtube.com? That's called a DNS server. The most common DNS server is probably just 8.8.8.8, or quad 8 is another way you'll hear some people say that. That is Google's DNS server. And Google actually has a second one. Quad 1s is Cloudflare's. That's a pretty common one as well. So a lot of times it'll ask you to put in multiple DNS servers. You can put in quad 8s, quad 1s, whatever. This DNS server may also be your domain controller. So if you know what that is, that may be, you're working with an on-prem network and you got a domain controller and you're connected to the domain, that may be the DNS. So now we can set this layer 3 information for this device as well. You can do this at home right now on your computer. You can go into your network adapter. You can say, hey, I want to edit my stuff. And you can say, all right, and I'm going to set each and every single one of these. Depending on the device you're on, it'll look a little different. Again, Windows likes to write their subnets like this, but like if you're on a Linux device, it may not. But we can just say, all right, this is going to be 10.2.2. We'll just say, just to be a little quirky, we'll say 115. Perfectly valid. Its subnet would be the same. Its default gateway, again, would be the exact same. And its DNS would be the same. All right. So we have our network designed and set up. On the other layer 2 network that we have, the other switch that we have, we'd have to do the same thing. We decided that we're going to use this subnet. So to write that out, we'd say 10.1.1.0/24. Or again, we could just write 255.255.255.0 here. Again, those things are equivalent. And let's say that our PC, we're going to give it an IP address of 10.1.1 because that's the network we're on, .215. Because again, we're just being a little quirky. We have to set the subnet, the default gateway, and the DNS. Which the subnet is 255.255.255. The default gateway is going to be the router for this network. It's going to be 10.1.1.1. And the DNS, again, we can set to quad 8, quad 1, or whatever. Now, to actually get these devices to talk to each other, your router has to allow routing between. It's your router's job to say, hey, if somebody is looking for something within this network, send it down there. So we type ping and we type this address on computer 1. It goes up as a frame to switch 1. Switch 1 says, that's not on my network. I don't know where that's at. Okay, I'm going to put that frame inside of a packet. So that's a key word here. Frames are layer 2 data encapsulations. Packets are layer 3 data encapsulations. So the packet comes up, says, hey, I came from this IP address. I have this frame inside of me. Do I have a route that goes to that IP address? If the router has that route, it'll say, oh yeah, I do. It goes down to switch 2. And then switch 2 will strip off the packet headers. We'll say, okay, cool. Now I have my frame again. Well, where are we going? Boom. There we go. And that's how that works. So there's our network with layer 3. That is our layer 3 stuff. All right. Now we are on to layer 4. Layer 4 is our transport layer. See, I don't even remember the names. If you have an interview coming up, you absolutely should remember the names, but I mostly remember the number. The number is what I'm used to dealing with mostly. Layer 4, this is going to be your ports that are being used. So if you think about let's say you want to go browse the web. That is going to happen on port 443. That is the protocol there is HTTPS. That is the secure version of HTTP. If you ever have if you're not getting a warning when you're browsing the web, this is the port that your computer is using. Different protocols use different ports. A lot of the more secure versions that we use today have insecure versions. So port 80 is HTTP, which is the unencrypted version of HTTPS. So if you go to a website that doesn't have this alerted, first of all, your browser will scream at you. It'll say hey, this isn't okay. But that's the port that's happening there. All different kinds of things use all different kinds of ports. So I'm trying to think of some examples here. SSH uses port 22. All these different kind of protocols, right? You have the protocols for email. You have the protocols for RDP, which is remote connection. It's Windows remote connection. All these different ports. Now, it's helpful to have these different ports. And this is how old firewalls used to work exclusively. Used to say, hey, let's say that I have a firewall here and I want to write a rule. The way that firewall rules are formatted is they say, okay, what is the source IP? What is the destination IP? Should write dest IP. What is the port? And do you want to allow or do you want to deny? Right? Are we going to let this go through, or are we going to block it? So most firewalls have an implicit deny. If you don't write an allow rule, it won't allow it. So let's say that we're tasked with allowing the people on our network to browse the web. Well, for them to do that, we have to know their source IP. So let's say we have a range. If we go back to our previous example, I remember we had this network, 10.2.2. I'm going to write .0/24. This is a subnet. So I'm writing a range of IPs here. What ranges am I writing? Well, from our subnet section, I'm writing these numbers will always stay the same, but this little octet, be anything from 1 to 255. So that's the range that we're dealing with here. We're going to allow them to anywhere. So usually you can just write any or whatever. And the port that I want to allow is 443 because that's my secure web browsing. All right, 443. And we're going to say allow. And there's my firewall rule. Now, firewall rules work sequentially. Whatever is at the top kind of goes through first, and things at the bottom can get kind of lost. So a lot of times you'll have a deny all at the bottom. You'll have anything from anywhere going anywhere, like do not allow. But the things on top, if you hit that rule on top first, you get to go. So let's say we have this firewall rule, but Bob has been abusing his web browsing privileges, and he's been going to very sketchy websites. And as the security guy, it's our job to not let Bob get on Firefox anymore. We would have to put that deny rule in above this rule, and then we would have to put in Bob's IP address to the IP address, and we have to write deny. So let me see if I can't figure out how to move this down. Okay, we move this down. Let's say that Bob's IP address is 10. Because he's on our network, so the network IP is going to be the same. Let's say he is IP 93. And that's the IP that we've statically set on his computer, and it's not going to change. He doesn't have privileges to change it. Again, going anywhere, we do not want to use 443. We're going to deny that. And that's what our firewall rule looks like. Of course, the more granular, the more specific you can be with your rules, the better. So maybe we want to say, hey, I want Bob from accounting to be able to, let's say we want him to be able to SSH to a server we have in a different network. IP address of that server. And I'm just using kind of an example here, but let's say that's that IP address. We'd allow it on port 22 because that's SSH. And we would say allow. And boom, as long as he doesn't get blocked by any of the rules above that, then he would be allowed to do that. In this example, he would not get blocked by the rule above it because it's a different port, right? So he's using a different port when he starts that communication. So yeah, that is what that is. If you have an interview, go learn the 100 most common ports, right? Learn those numbers. This is how old firewalls used to work. Most firewalls work at the application level now, which we will get into. All right, so now we're on to layer 5. Layer 5 is the session layer. Layer 5 is responsible for maintaining sessions and disconnecting them when they time out or when they get closed. That's all it is. I don't know a whole lot. We're getting into the territory where I know the least about, and I would recommend, if you're getting into hacking and security, the most important for you are these 3: layer 2, layer 3, layer 4, the data link, the network, and the transport layer. But there are some cool things that happen in layer 5. There was this VPN called NetMotion. I think they might have changed names now. But when they first came out, they had this cool feature where when you would disconnect from a network, it had the ability to basically hold a session open for you, which was really cool for VPNs in things like ambulances that would travel around and disconnect and have to connect to different networks, or first responders or police cars or all this kind of things. So that's an example of a security tool doing something very, very cool at layer 5. So it's important to know what it is, but we're not going to go into anything too in-depth here. Layer 6, same thing. This is the presentation layer, which is responsible for encryption. So your HTTPS encryption happens at layer 6. Again, we're not going to go into too much of it here, but if you're dealing with cryptography and that kind of thing and networking, that's typically happening at layer 6. When we're talking about encryption, when it comes to networks, we often have to think about, as security individuals, we can't do security on encrypted data, right? If you want to interact with data, it has to be unencrypted. You have to be able to read it. So you have some concerns there with, okay, where are we going to do our deep packet inspection? Where are we going to be unencrypting data? Are we going to have them come in through a spot? We're going to decrypt them and then look at the data and then encrypt them again and then send them, or what is that going to look like? So there's a lot of encryption questions we have to deal with as security guys. And of course, if things aren't encrypted, very, very easy to just man in the middle. Very easy to just listen in on what's happening. So that's what layer 6 is about. There's a lot of very complicated math when it comes to encryption, which can be very interesting. But again, we're not going to get into any of that today. Now we are on the very last layer, layer 7, which is the application layer. This is the layer that the user interacts with, right? This is all the pretty stuff that the non-IT folk deal with. So firewalls. We mentioned firewalls used to work on layer 4, but now they work on layer 7. These are called next-gen firewalls. You'll often see this written as NGFW, next-gen firewalls. Now, the reason that being able to specify the application gives us extra granularity is multiple things can be happening on one port, right? Like we talked about web browsing, we talked about HTTPS, which is port 443. If we go onto our firewall and we just say, hey, deny all 443, then they can't use any web browser. They can't use Firefox. They can't use your enterprise browser. But what happens when we have an enterprise web browser that we as the business control, and we have security controls on? So we're okay with our employees using our enterprise web browser, but not web browsing through anything else. Well, with just using the port, that doesn't really work so well, right? So you're going to have to kind of go in there and specify the application. Tons of applications use the same port, right? So this just gives us extra granularity. Again, going back to the HTTPS example, 443, so many different applications use this, and so many web apps are using this, right? So this application level firewall just gives us some extra granularity. So when you're dealing with a next-gen firewall, oftentimes we'll have almost like an encyclopedia. If you don't know what an application uses, you can look it up. Like, okay, hey, I'm dealing with Duo, which is a two-factor or multi-factor authentication platform. I'm like, hey, I don't know what ports this uses. I don't know anything about this. You can go throw it in there, and it'll pop out, hey, these are the ports it's using. This is that. But those are our 7 network layers. Again, to do a little bit of recap, as a security student, make sure that you are rock solid on these 3 layers here in the middle. Layer 2, layer 3, layer 4. The other layers are, I mean, of course, every single layer here is important, and the whole thing wouldn't work if one of them didn't work. But get familiar with these ones, and then go into where you get more interested. When we're talking about project ideas, in my last video, we talked about Active Directory, setting up an Active Directory server in your home lab, virtualized on your gaming PC. That is absolutely something you should do. To add in networking to that, you can do a virtual firewall. So what you're going to do is you're going to go find an open source firewall. You're going to install the image for it, and you're going to put it on a virtual machine. Now, the firewall I did when I was learning all this stuff was Ipv6. That one I've heard is getting a little bit sketchier privacy-wise. So I've heard about OpenSense, but I've never used this one. I'm not even sure that's how you spell it, but that's something that I heard of might be something interesting to look into. You can set up this firewall. You can use that as your layer 3 device, and then you can start to mess around with, okay, I'm going to mess around with my I'm going to mess around with my firewall rules and my ports and my protocols. I'm going to mess around with segmenting my LANs onto different local area networks, right? Or different layer 2 networks. I'm going to try to get these devices to communicate with each other, all that kind of stuff. If you guys have any questions, let me know. Oh, the last thing with projects I'm going to add is Cisco Packet Tracer. And what you can do in Cisco Packet Tracer is it will actually allow you to go into the command line and practice configuring switches and routers. I'm just going to write CLI configuration config. So these two things, if you want to get good at networking, are plenty, but it's a lot of work. If you guys have any questions, join the Discord and reach out to me. In the Discord, we have an engineering section. This is what I built this for. I want to see you guys make these projects. I want to see you guys do some cool stuff, and I would love to help you guys out. Thank you so much for watching this video. I'll see you guys in the next one. Peace.